All right, so we're going to start reviewing for your open-ended questions for the AP exam. So this is in your AP Calc review booklet. Looks like that. Handed them out right before we went out. The first unit is on max, mins, and points of inflection. So the first problem on page 2, you're going to try that one for homework. We're going to go through and do this page number 3 together. Unless the problem number up here is a 1 or a 2, a 1 or a 2 would be with a calculator. 3, 4, 5, or 6 is without a calculator. So we're going to assume that this is without a calculator. Now you're taking the exam in a much different form than I've ever seen it given. But so we'll just try and go through and do this without a calculator. So the first part, so they give us this graph and they tell us that the function is twice differentiable. We're looking at the graph of f prime, so you're looking at the derivative. That's important to remember. And we're only looking at the interval from -3 to 4. So this derivative stops here and stops here. They tell us that this derivative that you're looking at has horizontal tangents at -1, +1, and 3. So that looks like a horizontal tangent. It is. Same with that. Same with that. They're just verifying that that is indeed what you're looking at. And then they said the area is bounded by the x-axis and the derivative from -2 to 1, and from 1 to 4 are 9 and 12 respectively. So what I would suggest that you do, so they're saying this area from -2 to +1 has an area of 9. But remember, if we accumulate that from left to right, it's actually -9, since we're going left to right below the x-axis. Same thing with from 1 to 4, the area is 12, but the accumulation of that is actually -12, since it falls below the x-axis there. All right, so part A says find all of the x-coordinates where f has a relative maximum and give a reason for your answer. I'm just going to turn this a little bit this way. I have to just keep an eye and make sure that we're still, you can see what I'm writing down here. So for part A, where are you going to have a relative max? Well, remember, relative max is going to happen when the derivative changes from positive to negative. And the interval where the derivative is changing from positive to negative is right there at x equals -2. And then there's no other place where the derivative is changing from positive to negative. And remember, we're talking about the values of the derivative. So the values of the derivative are above the x-axis here, so positive. Values for the derivative are negative here below the x-axis. So this problem is actually, well, I'll go back at the end. I'll tell you about the points. Each problem is worth 9 points. So part B says on what open intervals from -3 to 4 is the graph of the original function concave down and decreasing. So f is going to be concave down. That's looking at the second derivative. And it's going to be concave down when the second derivative is negative. So where would the second derivative be negative? That's going to be the slopes for the lines tangent to f prime. I'm just writing this down because they're asking for the reason for your answer. So my slopes are negative all along here from -3 to -1. And then my slopes for my line's tangent, if you sort of think along the curve there, are positive. And then the slopes turn around and they're negative again there from 1 to 3. My original function f is going to be decreasing when the derivative is negative or below the x-axis. And that happens when, let's see, from -2 to 1 and from 1 to 4. You could kind of include that all in one interval too, if you like. if you want to separate it, you could write it that way. So I want the intersection of both of these things. So let's see, so I have from -3 to -1, and from -2 to 4. Well, from -2 to -1, they have that piece in common. And then this one has from 1 to 3, and this also includes 1 to 3. So those two intervals, -2 to -1, and from 1 to 3, the original function f is both concave down and decreasing. All right, for letter C, let me see how I'm doing up here. You can still see, I'll just write over a little bit. So for C, it says, what are the x coordinates for all of the inflection points? So the inflection points are going to happen where the slope's tangent to f prime, the first derivative, change sign, either positive to negative or negative to positive. So trying to remember not to abbreviate anything because that's what you need to do for your exam. So points of inflection occur at x equals. So think about slopes are negative, then slopes are positive. So x is -1. Slopes are positive, slopes are negative. So x equals 1. And then finally slopes are negative, then slopes are positive. So x equals 3. And I'm just going to write down exactly what I just said. The reason we knew that is because slopes tangent to f prime change signs. Right, I just described that. So specifically, how did they change? At -1 and -3, the slopes change from negative to positive, and at x equals 1, the slopes change from positive to negative. So that was very descriptive for them. And then the last piece, they want us to come up with an integral expression for f of x that's going to solve for f of 4 and f of 2, given that f of 1 equals 3. So that's going to look something like, it just might need an extra piece of paper here. So if I come up with an integral expression, so think about it. Your fundamental theorem of calculus says if you integrate the derivative from a to b, that gives you the original function evaluated at the upper bound minus the original function evaluated at the lower bound. So that's the integral expression or equation that they're looking for, and I just wrote it in general terms. So let me just slide this a little bit here. I think we're still good. So then they gave me these two conditions. They said f of 1 is 3, find f of 4, and find f of -2. Well, using this equation, if I integrate from, let's see some values that they gave us. So we could go from, let's see, 1, because I know that value, and the first thing I'm looking for is 4. If I integrate the derivative, I'll get f of 4 minus f of 1. Just plugging these values into that integral formula we came up with. So now I can fill in some of the values I know. The area from 1 to 4, back up top here, I think we can still see it. From 1 to 4, that area was 12, but we said since it's below the x-axis, it actually has a value of -12. F of 4 is what I was looking for, minus f of 1. Well, they gave us that value was 3. So I'm just filling in those pieces there. And if I solve for f of 4, add 3 to both sides, I'll get negative 9. We're going to do the same exact thing. I'm just going to slide this a little bit. I'm going to do the same exact thing to find f of 2, or negative 2. So if I integrate from negative 2 to positive 1, because that's the value they gave me, the derivative, that'll give me f of 1 minus f of negative 2. All right, and you can find this area from negative 2 to positive 1. They gave us that value back up here. Yep, you can still see that was negative 9. So I'm going to fill that in for the left side. And for the right-hand side, f of 1 is 3. F of negative 2 is what we were looking for. If I rearrange this equation, f of negative 2 will equal 12. Now I did say back in the beginning that each problem is worth 9 points. I'm going to slide this up just a little bit so we can see all of it. So for this one, here's where your points are awarded. Part A was 2 points. It was 1 point for coming up with x is negative 2, and then it was 1 point for saying why that was a relative max. So that one was worth 2 parts. For part B, this was worth 1 point. It was just one, I'm sorry, it was 2 points. It was 1 point for the correct interval, and it was 1 point for your reasoning, like how did you come up with all of this. So that was 2 points then. Part C, this one was 2 points as well. So this was coming up with each of the x coordinates for your inflection points, and then it was another point for y. It was this rationality here that the signs were changing for those slopes. So that was 2 points as well. And then part D obviously is 3 points. It was 1 point for coming up with this integral expression that they talked about, and then it was 1 point for each of these answers. So that was 3 points for that one. So there's your 9 points, and all of the FRQs are always based on a 9-point grade. You know, again, what is it going to be graded like this time? I'm not sure yet, so we'll keep looking. And that's it. So you're going to try page 2 is the first one, and you're also going to do page 4. They're very similar to what we just did.